Hello, good morning. Just want to touch bases with you guys because some people have said they've had some issues with the pH, pOH, H plus ion concentration, and OH minus concentration problems. So I'm going to do a couple of the problems here so you guys can understand what I'm doing. So I'm going to have to switch screens occasionally, so don't be freaking out. Okay, so I'm looking at the first box here, and it says that a 0.02 molar HCl. It's asking for the pH. So what does that mean? This means it's asking us to calculate the pH of the solution. Now I gave you guys a little square. Okay, it should look something like this. Okay, and if we look over here, we go ahead and say, what is the pH? Okay, and we look at the thing. pH is equal to the negative to 14 minus the pOH, or we go ahead and look and see other things. It's the negative log of the H. Look right here on the side, on the left-hand side, over here. It says that pH is equal to the negative log of the H plus ion concentration. Okay, it's the pH is equal to the negative log of the H plus ion concentration. So those are the two different ways you can figure out pH. Okay, so what are we given here? We're given an H plus ion concentration. How do we know it's an H plus ion concentration? Because HCl is an acid. Okay, and how we know it's a concentration? It's written in molarity, which is moles per liter. Remember that. Moles per liter. Okay, so now we remember that. So it's really just simple as we go back to the little square and we type in the negative log of the H plus ion concentration. So it was, let's see here, minimize this window and we get some Desmos here. So the negative log, where's the function for log? Negative log of the H plus ion concentration. So in this case, it was 0.02. And what do we get? We get 1.698, blah, 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 blah. Well, it's around to 2 decimal places because that's what we've been doing this entire semester. Actually, the entire year. So the negative log of that concentration is 1.70. That's our pH. Now, how do we figure out the pOH? Okay, so negative log is a 0.107. Okay, now let's go ahead and take a look at how do we figure out the pOH. So pOH can be calculated by one of the two ways. You see on the bottom here, it says that pOH is equal to 14 minus the pH. Or the other way to figure out the pOH is the negative log of the OH minus concentration. Now we don't have the OH minus concentration, but we do have the pH. We just calculated it. That was a 1.70. So in order to calculate the pOH, we take 14 and we subtract the pH, so the 1.70. So we go back to Desmos and we say 14 minus 1.70. And we get 12.3. So we go back to our little worksheet here. And we put 12.3. So that's pretty self-explanatory. Okay. So now we let's go to the next blocks downward here. Okay, and it says find the values of H plus ion concentration, pOH, and OH minus concentration. And we're given a pH for A of a lemon juice of 2.90. Okay, so we're already given a pH, so we have to work with that. So we want to first figure out the H plus ion concentration. How do we do that? Well, let's go to our little chart. And if we're looking for the H plus ion concentration, we look in the top left. Okay, and we see that H plus ion concentration is equal to either 1 times 10 to the negative 14th divided by the OH minus concentration, or it is equal to 10 to the negative pH. 10 raised to the negative pH. We're given a pH. So we can do that. So 10 raised to the negative pH. Okay, so we go back to Desmos or your calculator, but it's just easier for me to show you on Desmos. Okay, so we know that it's 10 raised to the negative pH. In this case, the pH was 2.90. Okay, remember, you make sure you put the negative in there, otherwise it's not going to work. Okay, so we get 0.001258.9, blah, 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 blah. Now let's go ahead and give you 2 digits past all the zeros, just so we have some numbers besides just 0.00. Okay, so we know the H plus ion concentration for this solution is 0.0013. Okay. And if we wanted to put that in scientific notation, so it's a little bit better, we could do that. So 1.3 times 10 to the negative 123. That's the concentration. You don't need to put it in scientific notation if you don't want to. Okay. Some of the very large numbers are very small numbers. We want to go ahead and do that though. Okay. So now we got to go ahead and figure out the OH minus concentration. So what is the OH minus concentration? So we go to our little handy dandy square, and we're trying to find the OH minus concentration. And we can get that by either calculating the OH minus concentration is equal to 10 to the negative pOH, or we can get it from negative log of the OH minus concentration. Do we have either of those? Do we have a pOH or a negative log of the OH minus concentration? No, we don't have that. But we have a pH. And when we're given a pH, remember, we can figure out the pOH. Okay, remember, it's pOH is equal to 14 minus the pH. So let's go back to Desmos. Okay, we're given a pH of 2.9. So let's go ahead, 14 minus 2.9. And that gets us our pOH. So, oops, our pOH for the third block over is going to be 11.1. And with a pOH, we can calculate the OH minus concentration. How do we do that? Well, we go back to our handy dandy square. And the OH minus concentration is equal to 10 to the negative pH. Okay, we raise it to 10 to the negative pOH, I'm sorry. So, 10 raised to the negative 11.1. Oop, not 111. 11.1. And we're going to get an answer in scientific notation, and that's acceptable. Give me 2 numbers after the decimal place. Okay, so the OH minus concentration in this is 7.94 times 10 to the negative 12. Now I just want to make sure. So the OH minus concentration is equal to 10 to the negative pOH. Okay, so that's a really small number, which makes sense because there's so much it's very acidic, so there's not very many OH minus ions in the solution. There's not very many basic ions in there. So that makes sense to have a really small number of the makes sense to have a really small number there. Now I think I might have messed up here, so let me go back to make sure. So pH is equal to 14 minus the pH. Okay, yep, that's my pOH. Yep, we're good. Okay. So, yep. Yeah, so that's how we figure that chart out. Sorry, my mind's a little foggy. It's been a little while since I've actually had to teach in person. So, so we look at the back side here. Let's just do the first column. sorry, the first row, because there's no real point to do anything else other than that, because you guys can figure that out from the rest. Now, let's make my window a little bit bigger here. So we're given an H plus concentration in the start with, and we want to figure out the rest of this crap. Okay, so how are we going to do that? Well, we're given an H plus ion concentration, so that means we can figure out a lot of things. We could just go in order, whatevers. Okay, but let's take a look. So we're given an H plus ion concentration at the top left corner. We need to figure out all that stuff. So what can we immediately figure out? So we're given an H plus concentration. We can figure out the pH, because we just to calculate the pH, we follow the arrow. Okay, the arrow is pointing down, so that's how we calculate the pH. So pH is equal to the negative log of the H plus ion concentration. So let's go ahead and pop open Desmos. So the negative log, negative function log of 1 times 10 raised to the negative third power. Oop. Okay, and we get a pH of 3. Now how do we get pOH? Well, we take 14 minus the pH, 3. So the pOH is 11. Okay, and then get the OH minus concentration. Remember that we go ahead and take the negative log of the pOH. So negative log of 11. Oop. I'm sorry. What am I looking for again? OH minus concentration. Okay, OH minus concentration. Our little square says that we need to go ahead and take 10 raised to the negative pOH. I'm so sorry. So, see, if it doesn't make sense right away, the numbers don't make sense. So 10 raised to the negative 11 point, what was it? Negative 11. So 1 times 10 to the negative 11. So is this acid, base, or neutral? We know that anything that has a pH higher than 7 is going to be a base, and anything with a pH lower than 7 is going to be an acid. And anything at 7 is going to be neutral. So we look at the pH. Is that greater than, equal to, or less than 7? In this case, it's less than 7. So we know that it's an acid. Okay. So let me go ahead and make the screen a little bit bigger so you can see what I'm talking about. And that's how we do all of those. So it's really just a bunch of manipulated numbers from our table here. Okay, I hope that was helpful. I'm going to go ahead and end the video now. If you have any questions, please shoot me an email and I can help you. Or we can go ahead and get on Google Meet and we can figure this out together.